All right, so two new rules today, both for the biconditional. We have biconditional introduction and biconditional elimination. These are both pretty straightforward rules and easily understood. So biconditional introduction tells us that if we have a proposition of the form if A, then B, and we also have the same conditional but running in the opposite way, so if B, then A, then we can put them together into the biconditional A if and only if B. So if A, then B, and if B, then A implies A if and only if B by biconditional introduction. And similarly, this is the same rule. If A, then B, and if B, then A goes to B if and only if A. So you can infer one or the other of these under the rule of biconditional introduction. Now, I think this is probably fairly intuitive to you, but you could use the truth table or you could use a refutation tree to show that if A, then B, and if B, then A is logically equivalent to A if and only if B. And we've actually mentioned that before. Now, biconditional elimination, again, very straightforward, allows us to take a biconditional and write either one of the corresponding conditionals underneath. So we can take A if and only if B and write if B, then A, or we can take A if and only if B and write if B, then A. This does not allow us to write them both down at the same time. It doesn't allow us to write the conjunction of these two. So it's not the exact opposite of biconditional introduction, but again, it's very intuitive. You're just taking one of the corresponding conditionals out and writing it down on the line below. So here, of course, you've only got, whereas with biconditional introduction, you had two lines that you need to cite. Here you only have one. All right, so let's just look at a couple examples of these. Let's see if we can do this proof. Go ahead and try it yourself, of course, first. All right, so you want to derive if S then K. Thinking backward, you say, well, how could I do that? Well, here's not S then K, but K if and only if S, which you now know you can get through biconditional elimination. So that makes you want R if and only if P. Is R if and only if P there? No, it's not there, but we are given if P then Q and if Q then R. And maybe you can see that if P then Q and if Q then R put together would give us R if and only if P by biconditional introduction. It would give us P if and only if R, which as written is a little bit more natural, but it will also give us R if and only if P, because we have if Q then R and if P then Q. Okay, so that gives us R if and only if P by 1 and 2 biconditional introduction. Then we take our familiar biconditional elimination rule and we get K if and only if S through 3 and 4. And then you can see the last step, yes, if S then K by 5 in biconditional elimination. All right, let's try one more. Go ahead and do this on your own. So here, this is using some knowledge from previously. We see that we have a disjunction. Anytime you see a disjunction, you want to be aware of the possibility that you can just construct it by or introduction, and you would or disjunction introduction. And if you had P, or if you had S, if S and R, you could do that. Now it looks like you have neither of these, of course, over here, but you do have P if and only if Q, and you have Q. So if you were to take the biconditional and turn it into and remove one of the conditionals, then you should be able to do this. All right, so if we did that as the first move, write if Q then P by 1 and biconditional elimination. And we have P immediately by 2, 3 and conditional elimination. And then just introduce if S then R by or introduction. All right, that's it. Let's go ahead and review what we've learned here. So these are all the rules that we know so far. We should know them. You have to, just like with the refutation tree system, you have to memorize these rules in order to be able to do the proofs. That's the way you'll be tested on them. But also, again, until these rules are in your head, there's a feeling of magic when you do them in a proof. So get them all into your head. Use the flashcards that are on the schedule if that helps you. And we are now ready to move on to two of the last derived or non-derived rules, basic rules, but they're different. They're called hypothetical rules, and we'll start to cover them in the next two lectures. Right now, let's just go ahead and do a little bit of review.